Hello everyone, welcome to my YouTube channel Exploring Civilworks. In this video I'm going to show you in 3 basic steps how to simply calculate the quantity of concrete needed in a given structural member, and finally deduce the number of bags of cement, sand or aggregate required to purchase from the market. Okay, so let's get started. Okay, so then first step is to know the volume of your structural member. Okay, and in this video we're gonna use a structural slab. Okay, and the volume of a structural slab is length times breadth times height. From the diagram over here, it is not drawn to scale, it's just for reference. It has a length of 12 meters by 6 meters in width, and the height is the same as the thickness. Okay, and it's 6 inch. So we are assuming that this is a residential building, so the thickness is standard, it's okay, unless maybe your engineer or your supervisor states otherwise. Okay, so when you punch this on your calculator, you are getting 10.8 cubic meters wet state. The wet state over here means water has been added to the mixture of the coarse aggregate, fine aggregate and cement. Okay, so water has been added to it. Yeah, so you can see from the diagram. Okay, so let's go to the next step. Okay, so in this second step we are going to calculate for materials in its dry state. Okay, initially what we did from the first step was in its wet state. Okay, we found for the volume where water has been added. Now we want to find for it where water has not been added, the quantity that we have to buy from the market. It's in a dry state, the number of bags of cement we have to buy. So let's say we want to know the quantity we have to purchase from the market in order to cast a slab of 1 cubic meter. When we do this, from there we can go back to deduce for the 10.8 cubic meter we found for in the first step. Okay, so let's do for 1 cubic meter of slab. But before then, you have to bear in mind some parameters. The density of our cement, this will be used during our calculation. So let's bear in mind, which is 1440 kilogram per cubic meter. The density of our sand and aggregates is between 1500 to 1600 kilogram per cubic meter. It depends. So we are going for 1500 kilogram per cubic meter. We are choosing a concrete grade of M20. Okay, for our calculation sake, M20 is okay. It comes with a mix ratio of 1:1.5:3. With the mix ratio, we have M15, M20, M25, M30, and so on. It depends, depending on the choice of your structural engineer or supervisor. He may opt for otherwise. Okay, so take note of that. So you could see that we have written note 4, volume of required materials have to be increased by 54% of wet volume. What this means is that our concrete is composed of mixture of different materials, and these materials, the sand, the aggregate, the cement, have voids in them. They have openings, and these openings, in the process of mixing them to get our concrete, after we have added water, evaporation takes place. Okay, so there are some losses that takes place. So this 54% over here act as a buffer, or it compensates for the loss we are going to experience during preparation of the concrete. Okay, so over here you will see that I've written total volume of materials equals 1 cubic meter plus 0.54. The 0.54 is the same as the 54% buffer. We have just converted it into decimal. So the total volume we are now anticipating is 1.54 cubic meter. So when we get this 1.54, the answer we are getting over there, we can now use it to deduce for the initial 10.8 we found. Okay, so let's continue. Let's go to the next step. Okay, so we are now going to calculate it component by component, and we go in for cement first, followed by the sand, then finally the aggregate. And we are going to do it simply by using a formula ratio over total ratio multiplied by the required quantity. The ratio, as I stated just now, a mixed ratio of 1:1.5:3. The one over here represents the ratio of the cement. So the ratio of the cement over its total ratio, which is 1 plus 1.5 plus 3, multiplied by 1.54. The 1.54 I explained initially that is our anticipated volume that we want to find. When we get that, then we can go back and find for the total volume. This is the anticipated dry state volume we want to find, 1.54. Okay, after we have added our buffer, the 54%. So when you punch this on your calculator, you are getting 0.279 cubic meters. However, we don't purchase our cement in cubic meters. Most of our cements are in kilograms. So this is where our density comes into effect. So we introduce our density, which is 1440 kilogram per cubic meter. So we multiply it by our volume in cubic meters, so that cubic meters cancels cubic meters, leaving our answer in kilogram. So when you do that, you get 402.9 kilograms, and it doesn't remain there. Most of our cements are in bags, so we want to know the number of bags. Okay, so by doing that, we know from our market a bag of cement equals 50 kilograms. Hence, to know the total bags, we divide our 402.9 kilograms divided by 50. We divide it by 50. Okay, when we divide it, we are getting 8 bags. So for every cubic meter of concrete that we want to cast, we have to purchase 8 bags of cement from the market. Okay, so that's it. Let's go for sand in dry state. With that too, we are going in with the formula ratio over total ratio multiplied by our required quantity, and its ratio over here too is 1.5. That's the ratio of the sand in the mixed ratio. So 1.5 over its total ratio multiplied by the 1.54. Punching this on the calculator, you are getting 0.42 cubic meter. Yeah, so if you want to know the quantity in kilograms, you just have to multiply it by the density of sand. However, we purchase our sand mostly in cubic feet, so you just have to do your conversion. Okay, so a cubic meter equals 35.31 cubic feet. So when you multiply it, you are getting 14.83 cubic feet. That's the quantity of sand we have to purchase from the market in order to cast a concrete of 1 cubic meter. Okay, so let's go to the final, which is the quantity of aggregate. Yeah. Okay, so with this final one, which is the aggregate in dry state, it also takes the same criteria as the others. Okay, ratio over total ratio multiplied by the required quantity. Its ratio over here is 3. From the mixed ratio, the ratio of aggregate is 3. So 3 over the total ratio multiplied by the required quantity. When you punch this, you are getting 0.839 cubic meters. So with this, we have to convert it into cubic feet, since that's how we purchase from the market. So 1 cubic meter equals 35.31 cubic feet. You multiply it, you get 29.66 cubic feet. If you want to know it in kilograms, just multiply it by the density of the aggregate, so that cubic meters takes care of cubic meters, giving your answer in kilograms. Okay, so now we have found for the number of bags of cement we have to buy, the quantity of aggregate, the quantity of sand we have to purchase for a cubic meter. So now let's go back to our previous task, which was to know the quantity of materials we have to buy for an area or a volume of 10.8 cubic meter for that wet state. Now we want to know its dry state. So to do that, you simply have to multiply our 10.8 by the answers we got over here. That of the cement, that of the aggregate, that of the sand in dry state. You multiply them by the 10.8. So when we take that of cement, you multiply 10.8 by the 8 bags we had in dry state, and we will be getting 86.4. So approximately 86 bags of cement would be needed in order to cast a slab of 10.8 cubic meter, right? With the sand, to the same thing, we multiply our 10.8 by 14.83 cubic feet, so we get 160.16 cubic feet of sand we have to purchase. With aggregate, we are multiplying 10.8 by 29.66, giving us 320 cubic feet of aggregate we have to purchase from the market. So these are our answers. These are the quantity of materials we have to purchase from market in order to cast a concrete of 10.8 cubic meter. Okay, so this is the end of our video. Keep watching, and please don't forget to subscribe to my YouTube channel, Exploring Civilworks. We'll be coming with you more exciting videos and simple videos in civil engineering works. Thank you very much. Bye bye.